3, 2, 1.
Hello, I'm James O'Loughlin. Welcome to Innovating for the Earth, the story of the development and use of new technology developed by Calix. It's technology that provides solutions to industry that can address global environmental and sustainability challenges such as crop protection, aquaculture, wastewater treatment, carbon reduction and more. And we've previously discussed how the technology was developed and how it works. Today, we're going to find out how the Calix technology can be used for carbon capture, utilisation and storage, and how it's helping industries create better environmental outcomes. And my guest is Calix's General Manager of Cement Decarbonisation, Daniel Rennie. Before he joined Calix, Dan helped establish the Global Carbon Capture and Storage Institute in Europe, and he also managed the European Commission's CCS demonstration project network. Before that, he worked in the electricity industry, so, he knows stuff. He joined Calix in 2014 to develop and coordinate the LEILAC projects, which are major projects to develop and demonstrate new and efficient ways of capturing carbon in the cement and lime industry. Welcome, Dan. Thank you for joining us. We've heard previously how Calix's technology can separate carbon dioxide from minerals. Can you just give us a quick reminder of how that incredibly complex process works?
Absolutely, and the context, because this is very much for the cement industry and for lime production too. And so this is produce cement or to produce lime, it needs to use limestone, which is a mineral, and almost half of that by its weight is released as CO2. So this is very much about processing that, and effectively by using indirect heating. So we drop this limestone down these special heated tubes that ensure that the CO2 released from that limestone is not contaminated. So it doesn't get mixed up with air or heating gases. And so we just get a pure stream of CO2 out of the top and then processed material down the bottom.
So there's different ways of separating carbon. What's the benefit of Calix's technology?
There are lots of different ways of separating carbon, oxy-fuel or post-combustion, which uses solvents such as amines. And these all separate gases from gases. They all require either additional chemicals or processes or energy. But this Calix technology being developed in LEILAC doesn't use any additional energy compared to a conventional plant. And it doesn't require those extra processes or energy. Therefore, in theory, once it's applied at school, at full scale, we really should be able to capture this unavoidable process CO2 for very low cost.
So there's lots of different stories, opinions about carbon capture, utilisation and storage, almost ranging from it'll save the world to the devil's work. What's your view?
Yeah, there are two main ones are that it's unproven and that it's expensive. Coming to the unproven bit, first of all, it's actually separating of carbon is used in lots of industries anyway. And the storage of this CO2 has been occurring at huge scale since the 1970s. In North America and in the 1990s in the offshore North Sea. With the Sleipner plant actually capturing and storing safely over 20 million tonnes of CO2 to date. And that's for natural gas processing. So in terms of, is it unproven? Well, it is proven. We can do it safely. And in terms of it being expensive, yes, it can be expensive, but it is expensive when there's no cost for emitting that CO2. So anything's expensive, but we're... A lot has changed in the past few years. We're really a lot of different incentives are being put in place, and new technologies such as Calix's, which is really bringing the cost down dramatically.
So, what are some of the industries you mentioned, one or two, where carbon capture, utilisation, and storage have been used, and industries perhaps where it could be used more?
Yeah. So carbon capture and storage can be applied to any plant that really emits CO2, particularly the power sector. But it's been used to date in natural gas processing, chemical fields, ammonia production. But for Calix's technology, it's very much this LEILAC application is for the cement industry, and the cement industry is responsible for around 8% of global CO2 emissions. And it's very difficult to abate that to get rid of or change those emissions because they come from the limestone itself. So that's a really big target. The lime sector we don't really talk very much about because it's a component in lots of different things. So by decarbonising lime, that lime is used to produce steel, iron, chemicals, paper, food, pharmaceuticals, and glass. And so it's really used in a lot of industries as well.
So looking at the project you're involved with capturing carbon in the cement and lime industry, tell us a little more about how that works.
Well, this LEILAC approach just simply replaces the part of the plant where that CO2 is emitted. So the LEILAC 2 project is proving that this can be retrofitted to existing plant, that it can be scaled up effectively, and developing a module that can be quickly and easily replicated. So LEILAC 2 will be capturing around 20% of a plant's emissions, and that will form the blueprint for going to 100% and then rolled out globally pretty quickly.
Wow. And I asked you before about industries that carbon capture might be used in. What about countries? How many countries are currently doing at least some of it?
Well, certainly for the capturing, it's occurring globally. It is used in natural gas processing. It's used in the chemical industry extensively. In terms of carbon capture and storage, in terms of that capture, there's been a lot of research and development into the power sector. But again, that is expensive just due to the fact that there have been no strong incentives to develop it and roll it out. And we've seen with solar and renewables how effective those incentives can be. So again, that's all coming, but that is required to drive those costs down.
And you say that the Calix technology is energy agnostic. What does that mean?
Well, effectively, we just need to heat up these steel tubes that we.
You don't care how you do it.
We don't care how we do it. Absolutely. Yeah. So we can use any energy or fuel source. We'll be using natural gas and coal and conventional things like that, but also alternative fuels, wastes that society can't use otherwise, but also far cleaner fuels and future fuels like hydrogen, biomass, and electricity.
What would a zero emission plant look like? You talked about capturing 100%. What would that look like?
Well, we'll be capturing using this LEILAC approach. It captures 100% of the process emissions. To get to zero emissions, that fuel side, that heating of the tube needs to have a zero emissions as well. So if it's using electricity or hydrogen or biomass with a LEILAC system, that's zero emissions. So that's a very cheap and effective way of doing it. Alternatively, if it's using fuels that do emit carbon, such as coals or some of those wastes, it can actually be combined with other carbon capture technologies, which can suddenly be a lot smaller to just capture those fuel emissions. And we see that as being the lowest way of getting to zero emissions or even negative emissions cement or lime production. And
are there benefits to using electrical power?
Well, as long as it's from a renewable source, then that's the really simple way of getting to zero emissions. But so it's a very clean and simple energy source to use with our technology. But we can actually use this as a hybrid approach, which is very interesting.
Oh, right. So that's electricity and fuel. How does that work?
That's right. So that's when, for example, whatever the host uses or wants to use, the host plant could be using these alternative fuels for 90 or 95% of the time. And then when the grid wants, it could very quickly switch to electricity. So normally when with electricity needs to be generated to the level that people actually use it. it's very difficult for the grid to get rid of more electricity than people need on the grid. And so with every grid needs this balancing at somewhere to send excess electricity. And with renewables that might be generating more energy at awkward times of the day, this provides a real service to the grid by load balancing, by stabilizing that grid. And it's a real benefit to any grid, but particularly with those with a lot of renewable sources of power on them.
And could increase the viability of renewables.
Absolutely, because it allows more renewables to be introduced and used on the grid because they know that it's not going to break anything.
Yeah. And what about competitors when it comes to the Calix technology for carbon dioxide capture?
There are really quite a lot. There are a huge number of different approaches for doing capturing carbon. They all need to be applied. They're all at different technology readiness. Some are more developed than others. They do all need to be applied. We don't really see them as competitors because, again, they can be used in conjunction with this LEILAC approach, and that provides a really low-cost way of getting to zero negative emissions. Cement and lime.
So when you talk about low cost, we're talking about big industrial technology. So I guess even low cost is, to many of us high cost, but low cost in proportion to all the other costs. Is it expensive? Is it commercially viable for industries to capture carbon in this way?
That's a very good question. I suppose from a consumer's point of view, if you're building your house, doing any of these carbon capture technologies would be a tiny increase to the cost of your house from building it from with cement. But coming to what an industrial producer means and what that means to be expensive, to date, the cost of emitting carbon has been quite low. Usually in the 5 to 10 euros or dollars per ton of CO2, if there's that cost at all. We're looking at a changing scenario where in Europe today, it costs around 50 euros a ton to emit 1 ton of CO2 into the atmosphere. With this LEILAC approach, we're aiming to capture and have all of the costs of compression and capital for around 25 euros per ton. So that's significantly lower than any cost of capture has been done in the past. So that's really what we're aiming to do. We do need to do quite a lot of work to get there, but that's what we're aiming for with LEILAC 2 as a first-of-a-kind retrofit and certainly at full scale. And then that's becoming commercially viable as long as there is something to do with that CO2 afterwards.
Yes, well, that brings us, okay, you've separated the CO2. What happens then? And where is it?
That's a really key issue. So that there are two ways, one of which it can be used. CO2 is used today. It's used in different sectors, and they can provide an income, particularly to these early movers or where there isn't any cost for emitting the CO2. But usually that CO2 does eventually make its way into the atmosphere, depending on the use.
So I'm just curious, what industries are using it?
The food industry is a typical one. So for your beer or your soda, that will use CO2. It can also be combined with energy to make new fuels as replacements for fuels. But again, those volumes of CO2 are relatively small compared to the cement industry, and the CO2 will eventually reach the atmosphere. Other examples.
Well, I'm just thinking about a listener who's wondering whether they should have a beer or not. They're thinking, if I have a beer, I'll get rid of some CO2. But on the other hand, it'll be inside them and it'll still be emitted in some form, won't it?
At some point, but we really shouldn't restrict beer drinking. But it's certainly a good use of CO2 and can encourage the more industries to start capturing their CO2.
All right, so bigger scale. One way of using the CO2 is to I guess sell it to an industry that is going to use it. What else?
Well, to actually store the CO2, to ensure that it doesn't reach the atmosphere. And again, we're talking about many hundreds, thousands of millions of tons of CO2 that will need to be stopped from reaching the atmosphere. There are a number of ways of doing that. One is to actually rebind it, to mineralize it, and it can actually be used in building products. So there's a really neat circular economy with the cement industry in particular, where it can be bound in building products or bound with recycled concrete fines or cement fines, and that stores the CO2. The trouble is that's only still under development, and even at full scale, that's only going to do a proportion of the CO2 that the cement industry generates. The alternative is actually to store it in the subsurface. So 2 kilometers beneath the ground, really, really deep, in either hydrocarbon fields. So when all of the natural gas or oil has been taken out, we know that those gases have been stored for millions of years, and so that CO2 can just effectively go back to where it's come from.
And how would it actually get there from the Calix, separation process? Physically, how does it get there?
Lots of different ways. When it gets to that store, it would just be injected down into a deep well, and to get it from the plant to that well, it can be for small volumes, it'd be by trucks or by trains, and for bigger volumes by barges, ships, and pipelines ultimately.
It is kind of weird to think that you might see a train going by and, well, I wonder what's in there, and it's carbon dioxide. It's strange, isn't it?
It could be the CO2 that's been part of your house or the bridge that you're driving over, and that's the CO2 that's just going off to be safely stored somewhere.
And then a couple of weeks later, you might drink it in a beer.
Absolutely.
So it's safe to store carbon dioxide?
Yes, but very safe. So we talked about depleted hydrocarbon fields. They're safe. The other big one are saline aquifers. So these are really very deep, very, very large stores that can hold all of the unavoidable process emissions forever. It's a very highly regulated industry. Again, just talking about Europe, they've got something called the European Union Storage Directive. Every single country here has had to put this into their legislation, ensuring that there are regulators there, that it's safe, and that it's constantly monitored. And there's a lot of experience in this gas storage. So, yes, it's a very safe activity. And
how might this sort of carbon capture contribute to the 2030 targets?
Well, any plant that can apply this carbon capture and storage or use and storage does contribute to the 2030 targets. Every plant is the equivalent of tens, hundreds of thousands of cars being taken off the road. But at a bigger scale, and particularly for 2050, carbon capture and storage is going to have to be applied to industrial unavoidable emissions at enormous scale. So the IPCC, they've done lots of modelling. They can't really model it for us to get to where we need to be without carbon capture and storage. In fact, to just quote them actually, CCS plays a major role in decarbonising the industrial sector in the context of 1.5 and 2 degrees C pathways, especially in cement. So again, there's nothing we can do to avoid these CO2 emissions. We really have to address them.
Yeah. And look, just project 15, 20 years in the future, be a bit optimistic and bullish about your technology. No one's going to listen to this in 20 years, so you're not really accountable if you get it wrong. But how far do you think you can get with carbon capture using the Calix technology? Where could we be in 20 years with it?
Well, I think we could be in a place where we are decarbonising almost every single cement plant globally. So we've got this in mind. Calix is designing this technology to be blueprinted, that it's actually taken up and used by local engineers just cheaply and quickly everywhere. So as long as there are those incentives to not emit the CO2, as long as there is that there's somewhere to put it, and that does require government support and societal support to ensure that we do decarbonise. But we really should be aiming very strongly to decarbonise every single cement plant and capture, and it's around 2 billion tonnes of CO2 per year by 2050. So it's a huge, huge job in front of us.
Yeah. So I sense you feel a sense of mission, and it's an important mission, isn't it? I mean, when you have a bad day at work, does that sense of being on an important mission, doing something that could be quite important for the world, keep you going?
Oh, absolutely. I mean, it's a great pleasure to be working in this industry. If I'm personally having a bad day, I don't worry too much because there's a superb team of people, both within Calix and all of our partners, really working very hard on it. But yeah, it's a really great pleasure to really work towards our futures.
And with the process of decarbonising, both in the cement industry and others, what do you feel is the biggest challenge over the next few years?
I think the biggest challenge is to ensure that there is that transport and storage infrastructure. So we're getting to the point where we should be able to capture this unavoidable CO2 emissions cheaply and efficiently, but as long as there are those incentives to do so and there's somewhere to store it, that's really the big challenge, and that really does require, it's not something the cement industry alone can do. It really does require governmental and wider societal support to drive this forward and ensure that we can address these, our society's unavoidable emissions.
So I guess every government's different, but where you are in France, is the government getting to the right place with that?
Well, yes, it is. Again, and I've got a lot of hope globally that the French government is doing a good job. But actually, globally, with the commitment to the 2050 Paris Agreement, and which was ratified effectively by every country, we are on the route to getting there, and this is just an inevitable part of it. Different countries will move faster or slower. But as long as the technology is there in place to give viable solutions, then it really does set a pathway that enables societies to decarbonise and governments to move. Dan,
you've answered every question that I had. Is there anything else you wanted to say?
Wherever you are and whoever you are, really do just ask questions of us, the industry, your politicians, because we really do need to decarbonise. It's one of the big challenges that we've got as a society, and really would just encourage dialogue if we can have it. And understanding.
Well, I mean, that's a particularly important message now, actually, with the pandemic, and people all around the world, their mind has been focused on the thing they're most anxious about, which for many people has been COVID. And sometimes when that happens, you forget about the thing you were anxious about before, which for many people, rightly so, was global warming. And so, yeah, it's a timely message to say that we are smart enough and our brains are big enough to start to worry about two things at once.
Yeah, absolutely, and unfortunately, we're all starting to feel it now with the climate changes that we're seeing. So I think it's becoming very real and present, unfortunately. But yes, we do have the knowledge, we've got the technology, and we know where to go. So it's looking positive.
That's a great note, a great optimistic note to end on, Dan. Thank you so much. Really interesting to talk to you.
Thank you. Great pleasure. Thank you.